Second to last example, and I always think more examples are better because then you can see, you have the opportunity to be exposed to different problems and how to do them. So I'm going to warn you at the beginning here. I'm not going to be, I'm going to be completely honest. These problems are going to be kind of long, just because we do have 3 variables now that we're going to be dealing with. So just brace yourself. But it's all right. We'll go through it step by step. So we're going to be calculating the triple integral over W, some region, in 3D space of z dv. And then where, and this is all given, W is region between, and now we're going to have planes. We're going to get fancy and incorporate some planes. Plane z equals x plus y, and z equals 3x plus 5y. Let's see what else we have. And lying over the following domain. And I'll write it here. D equals 0, 2 times 0, 1. Okay, so this is everything that we're given, and it's a lot, which is good because the more that you're given, the more information you have to work with. Okay, so what we have to determine, like I said before, the bounds are really important because once you know the bounds and you secure those, then you can basically just work out the problem mechanically, like you've practiced. So first of all, let's determine the bounds on z. So we have to figure out which of these planes is higher than the other, which one's on top and which one's on bottom. So the way we can determine that is, let's look at our x and y first, actually. So the bounds for x are going to be 0 and 2, 0 and 2, and our bounds for y are 0 and 1. Okay, so that's good. We actually have a rectangle, right? That's just some rectangle on the xy plane. So we see that both x and y are going to be positive in our domain, right? Because it can't go below 0, so that's good. So that tells us if we have z equals x plus y, and the other plane, z equals 3x plus 5y, if you plug in a given point, let's say, it could actually, well, let's not do 0, 0 because those would be equal, and that'll be inconclusive. So let's say 1, 1. We have the point 1, 1 because that's in our domain on the xy plane, right? So if you were to plug in 1, 1, over here you'd get 2, z equals 2, and over here you would get z equals 8. So that tells us that this one must be the top one. So this is on top. So I'm going to call that z2 of x comma y. And then this one has to be on the bottom. So this is our z1 of x and y. Alright? So our bounds for z explicitly are, this is going to be the bottom one. So that'll be x plus y. I'm just going to plug in the little formulas here for the equations for the plane. And on the top we have 3x plus 5y. Alright? Okay, so now we have our bounds, and we know that f of x comma y comma z is z, right? Because we got that from the problem, equals z. Now we can just plug everything in and then solve from there. So I'll set it up here, and then we'll continue on to the next slide. Okay, so let's set up 0 to 2. I'm just going to go with x's first. So x's are on the outside, and then we'll go y's as we work in, dy, and then we have our all-important z here. So the bounds for that are x plus y down here, and 3x plus 5y up there. And then dz And in the middle, we have our z. Okay, so this bottom thing here, this is our setup for the triple integral. Okay? All right, and we'll continue solving on the next slide. Okay, so what we're going to be doing here is, well, I'll just rewrite what we had before so we can look at it. 0 to 1, and then x plus y, 3x plus 5y, and z dz, dy, x, that's an x, dx. Okay, so let's look at the inner one first. We're integrating with respect to z. We don't have anything else in front, so we can just go ahead and do it. So 0 to 2, 0 to 1, okay. And then on the inside here, we get 1/2 z squared as z goes from x plus y to 3x plus 5y. So as you can see, it's going to get a bit long, but it's just tedious work. Not really like difficult. This is just algebra. Well, technically it's calculus, but anyways. So what I'm going to do first is move this 1/2 outside so we don't have to deal with it until later. Yay, procrastination. Okay, no, I'm not supporting procrastination. Anyways, that just came out. Okay, so I'm going to move that in front. So we have 1 over 2, and then the rest. So 0 to 2, 0 to 1, and then we're going to square these guys. So we have 3x plus 5y squared minus x plus y squared. All right? And then we have dy and dx. So, okay, now we're just going to do a little bit of arithmetic to simplify in here. Maybe that was the wrong word. Maybe it's more like algebra. I think it's algebra. Okay, so we'll get 9x squared plus 8xy times 2, 16xy. And then, nope, yeah, that's right. Plus 25y squared minus x squared plus 2xy plus y squared, right? Okay, and then we have dy dx. Okay, so I'm going to simplify on the inside, and then we'll go on from there. 0 to 2, 0 to 1, 9x squared minus x squared, 8x squared, 16xy minus 2xy, 14xy, and then we have a 25xy minus y, 25y squared minus a y squared, 24y squared, okay? Then we have dy dx. All right. So now, let's see. So now we're going to be integrating this inner one with respect to y. So that means holding all x's as constants, all right? Okay, so let's proceed. And we get 8x squared, that's just like a number, right, times y, plus, and now we have 14x over 2 times y squared, plus 24 over 3y to the third. Okay, and y is going from 0 up to 1. Alright, and then we have our dx sitting over there. Okay, so now we're at this point. Make sure you have this all copied down, because I'm going to move on to the next slide. Alright, so now what we get when we simplify is 1/2, 0 to 2, and then when we plug in 1, we get 8x squared plus 7x, and then plus and 8. And then when you plug in zeros, every term has a y in it, so those are just going to be minus 0. So I'm just going to abstain from writing those. Okay, so now we're to the point of single variable calculus, which is nice, and we're just going to integrate. So we have 1/2, and then we have 8 over 3 x to the third plus 7 over 2 x squared plus 8x. Okay, whew, that was a weird parenthesis. That made it worse. Okay, pretend this looks nice. Alright, good enough. Where x goes from 0 up to 2. Okay, and now we're just going to plug it in. 1/2, and then we have 8 over 3 times 2 to the third plus 7 over 2 times 2 to the second plus 8 times 2. And see how each of these has an x term in it, so when you subtract the x, plugging in 0 for x, then you're just going to get minus 0. Okay, so now let's just simplify here. And we get, okay, we're going to be getting a 8 times 8, so 64 over 6 plus 2 squared, 28 over 4, okay, and a 16 over 2, all right? So what this is going to turn out to be is just we can simplify this guy, so divide by 2, and you get 32 over 3, 32 over 3 plus 7 plus 8, so that is 32 over 3 plus 15, which is 45 over 3. So our final answer is going to be 77 over 3. And we are done with that problem. Okay? Alright, so I hope you followed along, and if not, I would suggest probably just backing up the video a little bit and then rewatching the part that is a little bit difficult for you until you understand it completely. Okay, so I have one last example, and it is a bit different than this one because they don't give you a specific domain. So let's look at that one.